In the deepest darkness of space, something unseen is pushing the universe apart. Galaxies drift like glowing embers on a cosmic wind, carried by a force we cannot touch and barely understand. This is not the story of stars or black holes. This is the story of the pressure behind existence itself. For most of human history, the night sky seemed eternal and still. Yet in the last century, astronomers discovered that space is not a quiet stage but a stretching fabric, expanding in every direction. At first, this expansion was thought to be slowing down, as gravity pulled everything back together like a tired heartbeat. Then came a shock that changed cosmology forever. Distant supernovae revealed that the universe is not merely expanding, it is accelerating, faster and faster, as if some invisible engine has pressed the throttle of reality. This unknown driver received a simple name: dark energy. It does not glow. It does not clump into stars. It does not form planets or people. And yet, it dominates the cosmos. About 70% of everything that exists is this mysterious pressure, silently inflating the space between galaxies. Matter, with all its atoms and stories, is only a minor guest in a universe ruled by something we cannot see. To measure this force, scientists built a powerful eye on Earth, the Dark Energy Camera. Mounted on a telescope in the Chilean mountains, it watches hundreds of millions of galaxies and maps their positions across enormous volumes of space. Each galaxy becomes a lighthouse, marking how the cosmic web has stretched over time. By tracing these patterns, astronomers can read the history of expansion like rings inside an ancient tree. Recent results from this camera refine the numbers that describe our accelerating universe. They suggest that dark energy behaves almost exactly like a constant pressure embedded in space itself. Imagine every cubic meter of emptiness filled with a faint but relentless outward push. It is weak compared to gravity near stars or planets, but across billions of light years, it becomes unstoppable. Like a whisper that never stops, it reshapes the destiny of everything. One model explains dark energy as a property of the vacuum, known as the cosmological constant. In this view, empty space is not empty. It is a reservoir of energy that does not dilute as the universe grows. As galaxies move apart, more space appears, and with it, more dark energy. The expansion feeds itself. Another possibility is more exotic, a dynamic field called quintessence, slowly changing over cosmic time, like a tide that never settles. Each model tells a different future for the cosmos, from endless cold stretching to sudden collapse or dramatic tearing apart. To visualize the scale, imagine the Milky Way and its neighboring galaxies bound together in a small island of gravity. Beyond this island, clusters of galaxies drift away so quickly that their light will one day never reach us. In trillions of years, the night sky of any surviving civilization will grow darker, emptier, lonelier. Dark energy does not destroy stars. It erases horizons. Yet this same force carries a poetic irony. Without dark energy, the universe might have collapsed long ago, crushed by its own gravity before planets or life could form. Expansion gave time for stars to burn, for heavy elements to grow inside their cores, for worlds to assemble, and for minds to awaken. The pressure that will one day isolate galaxies also allowed curiosity to exist. The dark energy camera data do not end the mystery. They sharpen it. They tell us that the acceleration is real, steady, and precise beyond earlier measurements. They whisper that Einstein's old idea of a constant cosmic push might be correct, but they also leave room for surprises. Tiny deviations in the pattern of galaxy clustering could hint that dark energy evolves, that the universe is more alive than we thought. Behind every calculation stands a question that sounds almost philosophical. Why does empty space have energy at all? Quantum physics predicts an enormous value, far larger than what we observe. The real universe shows only a faint echo of that prediction, as if reality itself dialed down its own intensity. This mismatch is one of the greatest unsolved riddles in science, a crack between theory and observation wide enough to hide a revolution. As telescopes grow more powerful and surveys more detailed, we approach the edge of a deeper truth. Dark energy may be a constant breath in the lungs of space, or it may be a signal that gravity itself needs rewriting. Either way, the acceleration of the cosmos is not just a distant phenomenon. It defines the ultimate fate of every galaxy, every star, every possible future observer. We live at a rare moment when the universe is old enough to reveal its expansion and young enough for us to see it. The dark energy camera looks outward, but its message points inward to the limits of human knowledge. Somewhere between galaxies, in the silent stretch of space, the force that shapes eternity is at work. And for the first time in cosmic history, a species small enough to be dust is learning how fast infinity is running away.